Hello students, my name is Professor Waugh, and I've been teaching college chemistry to students for over 31 years. For today, we're going to start learning about density. While density might sound a little bit scary, you'll soon learn that there's not much to it. In fact, you could even say that density calculations are just more dimensional analysis problems. All right, let's start class. Quick note before we begin, we have a website. There you can find all the notes we write for our videos. We also have quizzes and assessments, so go check us out. Thanks. Now let's talk about density. Density is the broken heart, mass over volume. So it's represented by the capital D, and sometimes I've seen it as a small q as well. Not mass over length or mass over area, it's always mass over volume. So it's grams per milliliter or grams per cubic centimeter, because you know a cubic centimeter and a milliliter are the same thing, or a femtogram over a cubic nanometer, or a pound over a cubic inch. So you can do this in English system, SI system, metric system, it doesn't matter. It just has to be mass over volume. So I want you to memorize the following. The density of water is 1.0 grams per milliliter, or 1.0 grams per cubic centimeter at 4 degrees Celsius. Now that's what we use in the laboratory all the time. So when you're doing your lab work and you've got to determine the density of distilled, which is pure water, nothing else is in there, make it your business. You better round to 1.0 grams per milliliter. Now, this is the same thing that relates to specific gravity, and I just wanted to throw this in. The specific gravity is a ratio of the density of a substance to the density of water. So I often call it unitless density. So whatever the density of the substance is, you divide it by the density of water, and that is called your specific gravity. And you'll see that as well in your calculation, so know it now. Okay. Let's work a simple problem. What is the density of a substance that occupies 7.88 milliliters and weighs 10.382 grams? Now, always look at your problem and pull out what is given. So what's given is the volume, which is 7.88 milliliters, and the mass, weight and mass are the same thing on planet Earth. That's 10.382 grams. Now the formula, as you know, is density is the broken heart, so that will be the mass over the volume. So when we plug in all of our data into the formula, the density is equal to the 10.382 grams divided by the 7.88 milliliters. Now remember, the 7.88 milliliters only has 3 sig figs, so your final answer must have 3 sig figs as well. So we always go with the least number of sig figs with division. If you don't know that, look at our previous videos. So the final answer is 1.32 grams per milliliter. Okay, now, density is a conversion unit. Remember that. So always write density as an equation. Sometimes it's hard for students to see this, so look below and let me show you. Here's an example. How many cubic centimeters are occupied by 6.892 grams of liquid butane? You know, that's lighter fluid. The density of butane is 0.60 grams per cubic centimeter at room temperature. Okay, so what were we given? We were given the mass, 6.892 grams, right? And we are given the density of butane as 0.60 grams per cubic centimeter. So you see how I took that density of butane and I made it into an equation. 0.60 grams is equal to 1 cubic centimeter. And the only thing we're talking about here is butane. Now, all we are going to do now is use that density to help us convert from 6.892 grams we can inverse that equation, put the 0.60 grams in the denominator, the bottom of our fraction, 1 cubic centimeter in our numerator, so the grams will, boom, cancel out, and then we get a total of 1.149 cubic centimeters. So that is what is going to be occupied by that mass of butane. Isn't that awesome? Okay, so I made this stupid little rap for my class. So sing it with me. Mass to volume, volume to mass, use the density. Mass to volume, volume to mass, use the density. You're going to do this over and over again, okay? Make sure you remember that. It's crazy, but it works. Thanks, guys. Thank you for attending class. To recap, density calculations are all about the broken heart, mass over volume. Much like dimensional analysis, when finding answers to density problems, you have to use what's given. From there, you make conversions to get the units you want. Now, although we didn't go too far into density calculations in this video, especially when it comes to specific gravity, we are preparing something special for that subject. So make sure you subscribe or visit our website if you want updates. Once again, thanks for watching. We are A Friend in Chem, and our mission is to help students learn introductory chemistry. Our email and website is in the description. So if there's any way we can help you, please contact us. We want you to be successful in chemistry, enjoy chemistry, and have fun with chemistry. Until next time, take care.